Welcome to the 56th tutorial in Python and the 6th part in the OOP series. In today's tutorial, we'll be taking a look at a special OOPS concept called inheritance. So make sure to be ready and let's get straight into it.
Last time, we took a look at a concept called as encapsulation, which makes our object's data into private or public. Now we look at another property of object-oriented programming, which is called inheritance. Inheritance allows one class to absorb the properties and methods of another. So let's say there's a class called parent, and there's another class called child. So the class which gives its features to the other class is called as a parent class, which we have over here, and it's giving its features to the child class. Let's take a look at an example of inheritance. Let's have a class called as a vehicle. Now, def init, self, comma, brand. So self.brand is equal to brand. So nothing new over here. It's almost everything we've done before. Then def start engine. So this will be a normal empty class just to give us a string. Self print s format string self.brand has started its engine. But where exactly are we gonna take a look at inheritance? Well, right over here. In this next line, we're gonna make a new class car. But let's say we want to make the exact same class, but with its own properties. So we have class car over here, a different class, but we want to mimic the same properties. So we just type brackets and we just put vehicle. So this tells Python to copy everything that was over here into here. And to make sure we don't result in any error, we just put pass. So it's not visible over here, but if we take a proper look at it, technically, all the stuff which we wrote over here is over here too, and with a pass at the end. To test this out, let's take my car is equal to a Ford. So now if I print my car.start engine and run the code, it gives us Ford has started its engine. But if you take a look over here, we're not typing vehicle, but instead we're using the car class. So we have a vehicle class with an init and a start engine method. Then we create a car class that inherits from it. So car doesn't define its own methods, but it can still use the ones from the vehicle because of its inheritance. Now, let's customize it a little bit. There are multiple vehicles, right? So once again, if I take the previous class of vehicle and we make a new type of vehicle, which is our bike, vehicle, and a unique property about a bike is that we can ring the bell. So def ring bell self print self.brand has ring bell, or to make it more grammatically correct, has rung its bell. So if I take my bike is equal to bike, a BMW bike, and we print my bike start engine. And we also print my bike dot ring bell, and then we run the code. As you can see, it shows in the output, BMW has started its engine and BMW has rung its bell. We extended the bike class by adding a ring bell method. This class still inherits the start engine from vehicle, but now also has its own personality. Now let's change the bit. We once again have vehicle, but we'll change from bike to a truck. But over here, let's change the method itself. We're going to override the parent method. So over here, as we saw before, def start engine in vehicle, we'll change it to def start engine self, and we'll make it print f, and we'll give a special statement for the truck, self dot brand roars to life with a heavy engine. So now if I go here and my truck is equal to truck Volvo, and my truck dot start engine, when you run it, Volvo roars to life with a heavy engine. It inherits the start engine method from the vehicle class, but changes it a bit. We've overridden the start engine method in truck. So this is how a subclass or child class can replace the behavior of its parent. So the name of the method stays the same, but the implementation of the method changes. Now there's another feature we can use. Let's make this a bus class, bus vehicle, and we'll put the colon and def start engine self, but we'll make it a little different over here. We'll use a new thing called as super. Super dot start engine self print f self dot brand, or this came as a couple, self dot brand checks all passengers before driving off. Now if we run it, bus, or let's take it a city bus, is equal to bus Mercedes city bus dot start engine. And if you run the code over here, as you can see, Mercedes has started its engine, but it also says Mercedes checks all passengers before driving off. So what exactly did the super function do over here? Well, if you want to keep the parent method but also add something more to it, you use super. So when you use super over here, super of the start engine, it takes the exact same phrase, print f has started its engine, and it puts it right over here. And along with that, we print another statement. So when we used the overriding thing, when we override our parents' methods, we completely remove them. But over here, we're just making a small change.
If this video helped you understand the basics of inheritance, make sure to subscribe to the channel and drop a like. Also, in the next video, we'll be covering a more deeper concepts of inheritance and something special known as method resolution order, or MRO in short. So make sure to be ready and stay notified for the next tutorial.